In this video, we're going to be exploring projectile motion, or how.
You got like 3 feet of air that time.
So get ready.
All right, launch position.
Roll the intro.
Do you feel the vibes?
An object in projectile motion only has an acceleration of 9.8 meters per second squared down. This is because it's only under the effect of gravity in the y direction. Now, this may sound a lot like free fall if you watched our video on free fall, and that's true, except in this case, we're going to add an x direction. The object isn't accelerating in x direction. You may think this is flying, but
This isn't flying, this is falling with style.
that's because this object isn't just in free fall.
She's a projectile.
It also has some components of its velocity in the x direction, so it's moving in both x and y.
Ipso facto.
Projectile motion. We're going to look at a case where the velocity initial is in both the x and the y direction. I would explain the problem, but I'm just going to show it.
1, 2, 3.
So I timed this clip, and it took about 4 seconds for the case to fall. I also looked at this image, and judging from the height of Gyatso being about 6 feet or 2 meters, I estimated that the height of the temple was 30 meters, and the distance from Gyatso to where the people were sitting was 20 meters. So that gives us our known information. We're then going to be solving for the initial velocity and the angle of the launch for the airbending to figure out how hard and at what angle Aang and Gyatso need to launch the cakes in order to hit their target. We're going to start with the x direction. So in this case, x final is equal to v naught x t plus our x initial, which we already know is going to be 0, since we're going to be calling the starting point 0. So we replace x final with the final distance that the cakes travel, which is going to be 20 meters in the x direction. And this is going to equal v naught x times t. And I know that this was launched in 4 seconds. So that means that this is 4. And now this is in meters, this is in seconds. If I divide, I get 20 divided by 4 equals 5 meters per second, and that gives me my initial velocity in the x direction. So in the y direction, I do have an acceleration that I have to deal with. So I'll get y final equals y initial plus v naught yt plus 1/2 ay t squared. And I know that ay is going to be minus g, or minus 9.8 meters per second squared, because that's the acceleration due to gravity. Now I know that my y initial is going to be 0, because I'm going to call the point that we're starting at the origin, or 0, 0. Y final in that case is down 30 meters, which means that it's negative 30 meters. And I know in this case that both my t's will be 4 seconds. So if I make those replacements, I'll get minus 30 equals 0 plus v naught y times 4 minus 4.9 4 squared. If I do this part, this 4.9 times 4 squared out, I'll get negative 78.4. This is just 4 v naught y, and this is minus 30. So I end up with 4 v naught y is equal to 48.4. And then I can divide by 4, and I get v naught y is equal to 12.1 meters per second. So that's for the y direction. When we combine them, we have to remember that these are vectors. So we have to add them as a triangle. So I'll have my Vx here and my V naught Y here. And this is what I'm looking for, this initial V naught. And then I also want this angle right here. So in that case, I know from SOHCAHTOA that my angle will come from the tangent of that angle being equal to the opposite, which is V naught Y, over the adjacent, which is V naught X. And so this would equal 12.1 divided by 5. So I can do the inverse tangent of 12.1 divided by 5. And that will give me the angle, which is 67.5 degrees. Now, in order to find the magnitude of the vector, I would have to take the two components and use the Pythagorean theorem. So V naught squared is equal to V naught X squared plus V naught Y squared. And when I do that, I get that V naught is equal to 13.09 meters per second. And this gives me my final answer as to how far, or how fast rather, they needed to launch them and at what angle. So they needed to launch the cakes at 13.09 meters per second at an angle of 67.5 degrees above the horizontal.
You're taking all the fun out of this.
So let's make it a little more fun. Let's look at a problem where we don't know the time, since time was integral in solving the last one. You may think that was a meme, and while it was, it's also our next problem. So Lord Farquaad is going to push the gingerbread man off the table. Since Lord Farquaad does not push the gingerbread man down while he pushes him off the table, we only have an initial velocity in the x direction. So V naught x is equal to V naught. I'm also going to assume that the table is 1 meter high and that the trash can is 30 centimeters or 0.3 meters away from the table where the gingerbread man starts to fall. With that information, we can figure out with what velocity was the gingerbread man pushed off the table. If I try to go straight for the problem, and I initially look at the x direction, I can see that x final is equal to x initial plus V naught x times t. And this becomes a problem. I know that my x final is going to be 0.3 meters. I know that my x initial is going to be 0, but I don't know V naught x, and I don't know t. So I have one equation with two unknowns, and that means I can't solve it. So now I have to look at the y direction instead. I can look at that y final equals y initial plus V naught y times t plus 1/2 ay t squared. And I know that y final is going to be -1 meter. Y initial is going to be 0. It's -1 meter, by the way, because it drops down 1 meter. I'm calling down the negative direction, ergo y final is negative down 1 for 1 meter. V naught y is also 0, since it's only launched in the x direction. Ay is going to be minus g, which is minus 9.8 meters per second squared down. And we know that t is what we're looking for so that we can plug it in to the other spot. Because when my y final is 1 meter down, or -1, that's when it's going to hit the bottom of this bucket. And that is the time that I'm looking for to figure out what my initial velocity in the x direction is, because that would be the time at which it is at 0.3 meters away from its starting location. So the two times line up, and therefore I can use this time and plug it into this time. Now rewriting this with all of my given information, I'll get -1 equals 0 plus 0 minus 1/2 9.8 t squared. Solving for t, I'll end up with t equals 1 over 4.9, t squared rather, equals 1 over 4.9, and this is 0.2. 0. And if I take the square root of that, I get that t is equal to 0.45 seconds. Now that I have this piece of information, I can bring this up to my x direction and plug that in there to solve for the initial velocity in the x direction, which we know is just equal to the initial velocity. Now, when I do that, I'll get 0.3 is equal to 0 plus v naught times t, which is 0.45 seconds. And I'll get that v naught, which is equal to v naught x. So v naught x equals v naught equals 0.3 divided by 0.45. This gives us 0.67 meters per second. Now, notice what I did here, and I separated the two directions. So I kept all my x direction stuff here, and my y direction stuff over here. And the only thing that went back and forth between them was time. This is what we do for two-dimensional problems. So hopefully this one shows you a little bit more about how these different types of directions relate to one another when solving for problems. All right, y'all, this was the last video in our Kinematics series. So at this point, you should be pretty good with Kinematics, and you should understand how to solve problems in 1 dimension, in 2 dimensions, and how to use vectors effectively to do that. Don't forget to like, comment, and subscribe. I appreciate it.